In 2022, a team of researchers in Peru fed thousands of aerial photographs into an artificial intelligence system and asked it to look for shapes the human eye had missed. The AI returned results within months. It found 168 previously unknown drawings etched into the desert floor. Figures that had been lying in plain sight for over 1,000 years, invisible to every satellite, every pilot, every archaeologist who had flown over that stretch of sand. Some of them were enormous, some were small and intricate. A few depicted creatures that don't match any known species in the region. And the unsettling part was not that the drawings existed. The unsettling part was the question nobody could comfortably answer. How many more are still out there, hiding in landscapes we thought we already understood? South America is not supposed to be a difficult continent for modern science. We have satellites. We have ground-penetrating radar.
We have LiDAR, carbon dating, DNA sequencing, isotope analysis, and a century of systematic archaeology behind us. And yet, every few years, something turns up on this continent that forces a room full of specialists to sit down, look at the data, and admit that the explanation they were expecting does not quite work. Today, we are going to visit 5 places in South America, 5 real, documented, well-studied discoveries, where the gap between what we found and what we can explain remains stubbornly, uncomfortably wide. We'll start in the flatlands of southern Peru, move to a cliff face overlooking the Pacific, cross into Bolivia to examine a single stone bowl that has been causing arguments for decades, return to Peru for a collection of skulls that don't look like anything else on record, and finish at a fortress near Cusco, where the stones are so large and so precisely fitted that engineers still argue about how it was done.
None of these mysteries require aliens, lost continents, or secret civilizations to be interesting. They are interesting because they are real, and because in every single case, the simplest question, how, still does not have a complete answer. Let's begin in the desert, southern Peru, the Nazca Plateau. About 450 kilometers southeast of Lima, there is a stretch of flat, dry land roughly 80 kilometers long. The surface is covered in reddish-brown iron oxide pebbles. Underneath, the ground is pale yellow. If you remove the top layer, scrape it away, push it aside, the contrast between dark and light creates a visible line. A line that can last for centuries, because this is one of the driest places on Earth. It rains less than 20 minutes per year here on average. There is almost no wind erosion. Whatever mark you leave on this ground stays. Someone, between roughly 500 BC and 500 AD, used that fact to create one of the most extraordinary art galleries on the planet. Except this gallery was not meant to be walked through. It was meant to be seen from above. The Nazca lines, and calling them lines barely scratches the surface, are a collection of geoglyphs spread across an area of nearly 450 square kilometers. Some are simple geometric shapes, straight lines running for kilometers, triangles, trapezoids, spirals. Others are enormous animal figures, a hummingbird spanning about 93 meters from beak to tail, a spider roughly 46 meters long, a monkey with a curled tail stretching about 93 meters across, a condor with a wingspan of approximately 130 meters, a pelican, or possibly a flamingo, depending on who you ask, reaching about 285 meters in length. These are not rough sketches. Many of them are made with a single continuous line. The hummingbird, for example, can be drawn without lifting a pen. The proportions are accurate, the curves are smooth, and the figures are so large that from ground level, you cannot tell what you are looking at. You see lines, ditches, cleared paths, nothing more. Only from the air does the picture emerge. This is the first question that has never been fully resolved. How do you design a figure that can only be appreciated from an altitude you cannot reach? The standard archaeological explanation is careful planning. The Nazca people, a pre-Inca civilization that flourished along the southern coast of Peru, could have used small-scale models and grids to scale up the designs.
Stakes and cords could have guided the workers. The actual construction would not have been physically difficult. You are removing a layer of pebbles a few centimeters deep. A small team could clear a large area in weeks. And that explanation works. It is plausible. It addresses the how of construction. But it does not address the why. And that is where the real discomfort begins.
Maria Rieke, the German-born mathematician and archaeologist who devoted most of her adult life to studying the Nazca lines, believed they formed a giant astronomical calendar. Certain lines, she argued, aligned with the positions of stars and solstices. She spent decades mapping and measuring, living alone near the desert, sweeping sand off the geoglyphs with a broom to keep them visible. Her dedication was extraordinary. But when later researchers tested her astronomical theory systematically, the results were mixed. Some alignments appeared to work. Many others were no better than chance. With thousands of lines running in every direction, some of them are bound to point at something in the sky. Other theories have suggested the lines marked underground water sources. The Nazca Plateau sits above a network of ancient aqueducts called pukios, sophisticated underground channels that tapped into the water table and brought water to the surface through spiral-shaped openings. Some researchers, including David Johnson of the University of Massachusetts, proposed a correlation between the geoglyphs and subterranean water flow. The idea is intriguing, but it has not been universally accepted. The correlation holds in some areas and fails in others. A more recent interpretation, supported by work from researchers at Yamagata University in Japan, treats the lines as part of a ritual landscape. Paths walked during ceremonies, pilgrimage routes connecting sacred points. The animal figures may have been offerings to the gods, visible from the heavens, meant to ensure rain, fertility, or protection. This fits with what we know about Andean cosmology, where the relationship between humans and the sky was central to religious practice. But here is the detail that changed the conversation entirely. In 2019, a team led by Masato Sakai at Yamagata University began using AI-assisted image analysis on high-resolution aerial photographs of the Nazca Plateau. By 2022, they had identified 168 previously unknown geoglyphs. Many of these were smaller than the famous figures, between 5 and 20 meters, and depicted humans, domesticated animals like llamas, and what appeared to be scenes of decapitation. By 2024, follow-up work had brought the total number of newly discovered figures even higher. Some estimates now suggest the plateau may contain well over 1,000 individual geoglyphs when the smallest ones are included. This changes the picture dramatically. The Nazca lines are not a handful of giant animal drawings in the desert. They are an entire symbolic landscape, layered, revised, and added to over the course of roughly 1,000 years. Different figures belong to different periods. Some overlap. Some appear to have been deliberately modified. And the disquieting question is not, how were they made? We have reasonable answers for that. The disquieting question is, what kind of culture pours that much sustained effort, generation after generation, century after century, into marks that no living person at the time could see as intended? What were they communicating, and to whom? If you have an answer, write it in the comments. Because after more than 80 years of serious study, the experts are still debating. Roughly 200 kilometers to the northwest, the desert meets the ocean. The Paracas Peninsula juts into the Pacific like a blunt finger, its coastline a wall of sandy cliffs dropping straight into the surf. The land here is almost as dry as Nazca, baked white and gold by the sun, stripped bare by salt wind. And on the northern slope of a hill facing the Bay of Pisco, someone carved a figure into the rock face that has been staring out to sea for what may be over 2,000 years. The Paracas Candelabra, or candelabro as it is known locally, is roughly 180 meters tall and about 60 meters wide. Those numbers are worth pausing on. The Statue of Liberty, from base to torch, stands about 93 meters. The candelabra is nearly twice that height. It is cut into the sandy hillside to a depth of roughly 60 centimeters in some places and up to 2 meters in others.
And despite the fact that it is carved into a slope exposed to Pacific winds, it has survived for centuries without being erased. Part of the reason is the composition of the soil. The hill is made of hardened calcium phosphate, essentially minerite or hardpan, which is far more resistant to erosion than loose sand. But the preservation is still remarkable. This is an exposed coastal slope. Storms, earthquakes, landslides. The Peruvian coast has no shortage of forces that destroy things. And yet the candelabra remains. From the sea, the figure is visible from a distance of roughly 20 kilometers on a clear day. Sailors approaching the coast would have seen it long before they could make out any other detail on shore.
And here is where the mystery sits. Nobody knows, with certainty, who made it, when, or why. The most common association is with the Paracas culture, the same civilization connected to the elongated skulls we will discuss shortly. The Paracas flourished along this stretch of coast from roughly 800 BC to around 100 BC. If they created the candelabra, it could be over 2,000 years old. But the dating is not firm. Some researchers have suggested it could be more recent, possibly connected to the colonial period, or even to José de San Martin's independence campaign in the early 19th century. That theory, however, has very little supporting evidence and is not widely accepted. The shape itself invites interpretation but resists confirmation. It is called a candelabra, but it does not obviously resemble one. Some researchers see a trident.
Others see a cactus, specifically the San Pedro cactus, which contains mescaline and was used in Andean shamanic rituals for thousands of years. The three-branched form, with smaller branches extending from each arm, is visually consistent with the branching pattern of certain cacti. If the San Pedro interpretation is correct, the candelabra may have been a sacred marker, a signal visible from the sea that identified this stretch of coast as a place of spiritual significance. The Paracas Peninsula does contain one of the richest concentrations of ancient burial sites in South America. The famous Paracas necropolis, excavated by Julio Tello in the late 1920s, yielded hundreds of mummy bundles wrapped in some of the finest textiles ever produced in the pre-Columbian world. The navigational theory is simpler and has its own appeal.
A figure this large, this visible from the water, could have served as a landmark for coastal sailors, a way to identify the bay, avoid dangerous rocks, or locate a safe landing point. Ancient Peruvian cultures were skilled maritime navigators. The Moche, the Chimu, and the Inca all used balsa wood rafts for long-distance coastal trade. A landmark carved into a cliff would have been enormously useful. But the navigational theory has a problem. If the sole purpose was practical orientation, why make the figure so elaborate? A simple cross, a line, a circle, any large marking would serve the same function. The candelabra is detailed, symmetrical, and carefully proportioned. It looks intentional in a way that goes beyond simple utility. And then there is the stranger fact that rarely gets mentioned. The candelabra is not the only geoglyph on the Peruvian coast. Smaller figures and lines have been identified at various points along the shoreline, many of them poorly studied. The candelabra may be the most dramatic example of a much larger tradition of coastal marking that has never been fully mapped or understood. What was being communicated? To whom? And why did it need to be visible from the sea? The cliff does not answer. It just holds the shape, year after year, while the Pacific crashes against the rocks below. Now we leave Peru and cross the border into Bolivia. We head southeast, climbing into the Altiplano, the high plateau of the Andes, sitting at roughly 3,800 meters above sea level. The air is thin. The landscape is vast and flat, ringed by snow-capped mountains. And at the center of this plateau sits Lake Titicaca, the largest lake in South America by volume, straddling the border between Peru and Bolivia. Its surface covers about 8,370 square kilometers, an area slightly larger than the island of Crete. It sits at an altitude of 3,812 meters, making it the highest navigable lake of its size in the world. Near the southern shore of the lake, about 70 kilometers from the city of La Paz, lies the archaeological site of Tiwanaku.
This was the capital of one of the most important pre-Inca civilizations in the Andes, a culture that dominated the region from roughly 500 AD to around 1000 AD. Tiwanaku's architecture, its carved stone gateways, sunken courtyards, and precisely cut blocks, has been studied for over a century. But the object we are interested in was not found at Tiwanaku itself. It was found nearby, reportedly by a farmer sometime around the 1950s, near a place called Chua on the shores of Lake Titicaca. It is a stone bowl, about the size of a large cereal bowl, made of brown-gray stone. It is known as the Fuente Magna. For decades, it sat in storage at the Museo de Metales Preciosos in La Paz, attracting little attention. Then, in the late 1990s and early 2000s, researchers began to look more closely at the inscriptions carved into the bowl's interior surface.
And that is when the argument started. On the outside, the bowl is decorated with motifs that look broadly consistent with Andean iconography. Zoomorphic figures, possibly pumas or serpents, in a style that could fit within the Tiwanaku artistic tradition. Nothing unusual there. But on the inside, particularly in the upper register, there are symbols that some researchers have argued bear a resemblance to Proto-Sumerian cuneiform, the writing system used in ancient Mesopotamia in what is now Iraq more than 5,000 years ago. If that comparison is accurate, it would be one of the most explosive discoveries in the history of archaeology. It would imply some form of contact, direct or indirect, between Mesopotamian civilization and South America thousands of years before Columbus, thousands of years before the Vikings, potentially during the 3rd or 4th millennium BC. The distance between Sumer and the Altiplano of Bolivia is roughly 14,000 kilometers across the Atlantic Ocean through either Central America or around the southern tip of Africa. The idea that such a connection existed in the Bronze Age contradicts virtually everything we think we know about ancient seafaring. The strongest proponent of the Sumerian connection was Clyde Winters, an independent researcher who published analyses of the Fuente Magna inscriptions and argued that they could be read using Proto-Sumerian sign values. Winters also linked the bowl to the Aymara people, the indigenous inhabitants of the Lake Titicaca region, suggesting deep cultural connections between the Aymara and ancient Near Eastern civilizations. The mainstream academic response has been, to put it carefully, deeply skeptical. Most Sumerologists and Mesoamerican specialists who have commented on the Fuente Magna dismiss the cuneiform comparison.
The symbols, they argue, are superficially similar to Sumerian signs, but do not form coherent words or grammatical structures in any known Sumerian dialect. The resemblance may be coincidental, or it may be a case of pareidolia, the human tendency to see meaningful patterns in random shapes. Simple geometric motifs, lines, circles, wedges, triangles, are common to virtually every early writing system and decorative tradition in the world. Finding visual overlaps between unrelated systems is easier than it sounds. There is also the provenance problem. The Fuente Magna was not excavated in a controlled archaeological dig. It was reportedly found by a farmer decades before any researcher examined it. There is no stratigraphic context, no associated artifacts, no carbon dating of the surrounding material. We cannot say with certainty when the bowl was made, what it was used for, or whether the interior inscriptions are contemporaneous with the exterior decoration.
It is even theoretically possible, though no one has presented strong evidence for this, that the interior markings were added later. If this is the kind of mystery that pulls you in, the kind where a single object can threaten an entire framework of history, then subscribe to the channel, because stories like this come up far more often than you might expect, and they almost never make it into the headlines. The Fuente Magna remains in Bolivia. It has not been subjected to the full battery of modern analytical techniques: petrographic analysis of the stone, detailed 3D scanning of every inscription, comparison with comprehensive databases of both Andean and Mesopotamian symbols using current computational methods. Until that work is done, the bowl sits in a strange limbo. Too unusual to ignore, too poorly documented to accept, and too controversial for most academics to touch.
What is carved on the inside of that bowl? Probably local decoration, misread by hopeful eyes.
Possibly something far stranger. The honest answer is that we do not know, and the dishonest answer is any claim of certainty in either direction. We return to the coast of Peru. Same peninsula, same dry, wind-blasted landscape. But this time we are going underground, into the burial sites of the Paracas culture. In 1928, Peruvian archaeologist Julio César Tello, widely regarded as the father of Peruvian archaeology, excavated a massive necropolis on the Paracas Peninsula. Inside, he found hundreds of mummy bundles, many of them wrapped in extraordinarily fine textiles. The colors were vivid, the weaving was intricate. Some of the cloths contained over 200 threads per inch, rivaling the finest fabrics produced anywhere in the ancient world. But the textiles were not the most controversial part of the discovery. The skulls were.
Many of the individuals buried in the Paracas necropolis had dramatically elongated heads. Skulls stretched upward and backward into shapes that look, to a modern eye, startlingly alien. Some of them are so extreme that the skull appears nearly twice the height you would expect for a normal human cranium. Cranial deformation, the practice of deliberately reshaping a child's skull during infancy by binding the head with boards, cloth, or other devices, is well documented across many ancient cultures worldwide. It has been recorded in Mesoamerica, in parts of Africa, in the Pacific Islands, in ancient Europe, and extensively in the Andes. The bones of a newborn skull are soft and malleable. Sustained pressure during the first years of life can produce permanent, dramatic changes in skull shape. This is the mainstream explanation for the vast majority of the Paracas skulls, and it is almost certainly correct for most of them. The Paracas culture practiced cranial modification as a mark of status, identity, or group affiliation, much like the Maya and other Andean civilizations. The controversy, and it is a real controversy, not an invented one, centers on a subset of skulls that display features some observers have found difficult to attribute solely to intentional deformation. Standard cranial deformation changes the shape of the skull, but does not change its volume. The cranial capacity, the total interior volume, remains essentially the same as an unmodified skull because the bone is being redirected, not expanded. You are reshaping the container, not enlarging it. Several of the Paracas skulls, however, have been described as having a cranial volume that appears significantly larger than the human average. Juan Navarro, the director of the Paracas History Museum in Ica, who has handled many of these specimens directly, has noted that some skulls appear to be up to 25% heavier than typical human skulls of comparable body size. There are also structural observations that have fueled debate. A normal human skull has two parietal bones, the large bones that form the top and sides of the cranium, joined by a suture called the sagittal suture running front to back along the midline. Some of the Paracas skulls have been described as appearing to have a single parietal plate rather than two, with the sagittal suture absent or extremely difficult to identify. Now, it is important to pause here and be precise about what the evidence actually shows. The absence of a visible sagittal suture is unusual, but not unheard of in human pathology. A condition called craniosynostosis causes premature fusion of cranial sutures, and it can make suture lines invisible on the exterior surface of the skull. It is rare but documented. The larger cranial volume claim is also debatable. Accurate measurement of cranial capacity requires careful methodology, and working with ancient, often fragile, sometimes incomplete skulls adds uncertainty. In 2014, Brian Forrester, a researcher and author who has written extensively about the Paracas skulls, arranged for DNA samples from several specimens to be sent to independent laboratories. Early reports of the results suggested unusual mitochondrial DNA haplogroups, genetic lineages that did not match known Native American, European, or Asian populations. These preliminary reports generated enormous attention online. However, the scientific community has treated these results with caution. The samples were not collected or processed under controlled archaeological conditions. Contamination is a serious concern with ancient DNA work. The laboratories involved were not all specialists in ancient DNA extraction, and the results were announced through press releases and interviews rather than through peer-reviewed publication, which means they have not been subjected to the full process of independent verification and critique. As of today, the most widely accepted explanation remains cultural. The Paracas skulls are the result of intentional cranial deformation practiced over many generations. The unusual features that have attracted attention, the apparent volume differences, the structural anomalies, may be explained by a combination of extreme deformation techniques, natural variation, pathological conditions, and measurement difficulties. But most widely accepted is not the same as case closed. The Paracas skulls have not been subjected to the kind of comprehensive, large-scale, peer-reviewed ancient DNA study that would settle the question once and for all. The samples exist. The technology exists. The study has not been done, at least not at the scale and rigor that would satisfy the broader scientific community. Until it is, the skulls sit in museums along the southern coast of Peru, staring out through glass cases with those strange, elongated profiles, waiting for someone to ask the right questions with the right tools. What do you think the full DNA analysis will eventually reveal? If you know someone who finds this kind of mystery as fascinating as you do, share this video with them, because these are the conversations that deserve more people at the table. We end where the Inca Empire began, or rather, where it reached one of its most spectacular expressions. Just outside Cusco, the ancient capital of the Inca, at an altitude of roughly 3,700 meters, there is a structure that has confused every engineer who has ever tried to explain it on paper. Sacsayhuaman. The name is Quechua, and it is sometimes translated as satisfied falcon, though the etymology is debated. What is not debated is the scale. The site sits on a steep hill overlooking Cusco from the north. Its most visible feature is a series of 3 massive zigzag walls, terraced into the hillside, stretching for roughly 600 meters. The walls are made of enormous limestone and andesite blocks, dry-fitted, meaning no mortar, no cement, no adhesive of any kind. Just stone against stone, shaped to fit together so precisely that in many joints you cannot slide a razor blade between the blocks. The largest stones in the lower courses are staggering. The biggest individual block is estimated to weigh somewhere between 120 and 200 tons, depending on the source, roughly the weight of a fully loaded Airbus A320. Others range from 50 to 100 tons. These are not bricks. These are massive, irregularly shaped boulders, each one cut with multiple angles and faces, each one fitting against its neighbors like a piece in a 3-dimensional jigsaw puzzle. And this is the detail that makes engineers uncomfortable. The blocks are not rectangular. If they were uniform rectangles or cubes, you could explain the fitting relatively easily. You cut flat surfaces, you stack them, you adjust. But the stones at Sacsayhuaman are polygonal. They have 5, 6, sometimes 12 or more faces, and every face is precisely matched to the adjacent stone. The joints are not just tight, they are tight across complex, curved, angled surfaces. How do you do that with stone tools? The Inca did not have iron. They did not have steel. Their hardest metal was bronze, which is softer than the granite and andesite they were working with. They did not have the wheel in a functional engineering sense. They did not have written language. They did not have draft animals large enough to haul 100-ton blocks. Llamas, their primary domesticated animal, can carry about 30 kilograms. What they did have was an extraordinary mastery of stone. Inca stonemasonry, a technique modern researchers sometimes call ashlar masonry when referring to the fitted block style, is among the finest ever produced by any civilization. The technique appears at Sacsayhuaman, at Ollantaytambo, at Machu Picchu, and at numerous other Inca sites across Peru. The leading explanation for how the polygonal joints were achieved involves a process of trial fitting. Workers would have suspended or positioned one block near another, marked the high points of contact, removed the block, chiseled away the high points, and repeated the process, again and again, gradually improving the fit with each cycle. This is painstaking work, but it is not impossible.
Experimental archaeologists have demonstrated that reasonably precise fits can be achieved this way, though usually with smaller stones and with considerable time investment. Jean-Pierre Protzen, a professor of architecture at the University of California, Berkeley, spent years studying Inca stonework and conducted practical experiments at the quarry site of Cachicata near Ollantaytambo. He showed that the Incas' stone hammers, rounded river cobbles of extremely hard material, could effectively shape and dress the faces of large blocks. His work demonstrated that the tools were adequate for the task, at least in principle.
But principle and practice are different things when you are talking about a 150-ton block of andesite being moved from a quarry several kilometers away, dragged uphill to a construction site at 3,700 meters altitude, and then fitted into a wall with tolerances that would impress a modern machinist. The quarries for Sacsayhuaman's largest blocks have been identified. Some of the limestone came from relatively nearby, within a few kilometers. But the larger andesite blocks appear to have been sourced from quarries farther away, possibly in the Rumicolca area, roughly 35 kilometers from Cusco. Moving a 100-ton block 35 kilometers over mountainous terrain with no wheeled vehicles and no draft animals stronger than a llama is a logistical problem of the first order. The Inca are known to have used a system of organized labor called mita, a form of mandatory public service in which communities contributed workers for state projects on a rotating basis.
The labor force available for major construction projects was enormous. The Spanish chronicler Garcilaso de la Vega, writing in the early 17th century, claimed that 20,000 to 30,000 workers were involved in building Sacsayhuaman. The construction reportedly took several decades. Even accounting for the exaggeration common in colonial-era sources, the scale of organized effort was clearly massive. Ramps, levers, rollers, and human muscle, applied on a vast scale over long periods, can achieve things that seem impossible when you imagine a small team working on a deadline. The Egyptian pyramids were built the same way, and while we still argue about the specific methods, nobody seriously suggests the Egyptians lacked the capacity to do it. But there is a difference between the pyramids and Sacsayhuaman, and it is worth being honest about it.
The Great Pyramid is made of roughly 2.3 million blocks, but most of them are relatively uniform limestone blocks averaging about 2.5 tons each. The engineering challenge is one of scale and logistics, moving millions of moderate blocks. At Sacsayhuaman, the challenge is different. The blocks are far larger, far heavier, and far more irregular. The precision is not across flat surfaces, but across complex polygonal joints, and the whole thing was done at high altitude, on difficult terrain, without metal harder than bronze. There is another detail that deserves attention. Sacsayhuaman, as it stands today, is a fraction of what it once was. When the Spanish arrived in Cusco in 1533, they were astonished by the fortress. Several chroniclers described it as one of the most impressive structures they had ever seen. But over the following decades and centuries, the Spanish systematically dismantled large portions of the site, using the stones as building material for colonial churches, houses, and administrative buildings in Cusco. Much of colonial Cusco was literally built from the stones of Sacsayhuaman. What remains today is primarily the lowest courses of the zigzag walls, the stones that were too large and too heavy to be worth moving. The upper portions, the interior structures, the towers that once stood on top, all of that is gone. According to Spanish accounts, the site originally included 3 large towers, underground passages, and interior rooms sophisticated enough to serve as a royal residence. None of that survives. So when we look at Sacsayhuaman today and marvel at the stonework, we are looking at the foundation, the part the Spanish couldn't be bothered to take apart because the stones were simply too enormous. The actual building that sat on top of those foundations was, by all accounts, even more impressive. One final point. In 2008, and then again in subsequent years, researchers using geological surveys and ground-penetrating radar identified what appear to be additional structures beneath the surface at Sacsayhuaman. Chambers, tunnels, and spaces that have never been excavated. The Peruvian Ministry of Culture has been cautious about allowing large-scale excavation at the site, due to both preservation concerns and the complexity of working in what is essentially a national monument. What is under Sacsayhuaman? We do not fully know. The ground-penetrating radar says something is there. The Spanish chroniclers said tunnels existed. And the archaeologists have not yet been given the resources or the permission to find out. 5 places, 5 sets of questions, and one pattern that is hard to ignore. In every case, the physical evidence is real. The Nazca lines are on the ground. The candelabra is on the cliff. The Fuente Magna is in a museum. The skulls are in display cases. The stones of Sacsayhuaman are still standing, precisely where they were fitted 5 centuries after the Spanish tried to take them apart. And in every case, the gap between what we can see and what we can explain is not a gap of imagination. It is a gap of method. We know these things exist. We can measure them, photograph them, scan them, date them. What we cannot do in any of these cases is reproduce the full chain of creation from start to finish and say with complete confidence, this is exactly how it was done. This is exactly why it was done, and this is exactly what it meant. That does not mean the answers are unknowable. It means the work is not finished. It means the tools are getting better. AI is finding drawings in deserts. LiDAR is uncovering structures under jungle canopy. Ancient DNA sequencing is becoming more precise every year. The next decade of South American archaeology may answer questions that have been open for a century. But right now, in this moment, the honest position is the uncomfortable one. We are looking at the evidence. We are seeing things we did not expect, and we are not yet able to explain all of it. The desert, the cliff, the bowl, the skulls, the stones, they are all still waiting. And the only thing more unsettling than a mystery that refuses to be solved is the possibility that we have been asking the wrong questions all along.